Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. This is kind of awkward because my screen was frozen for a little bit. So you probably saw me like chewing the rest of my dinner. You probably saw my computer turn on and off, like my screen turn on and off. I couldn't see what was happening on my screen. And so I was watching the live literally from my phone to try to figure out where we were at. And then finally my computer like caught up and wasn't frozen anymore. So now we're good to go. Now I can see what I'm doing. You can see me. I can't see you, but I can see me. And so we are ready to roll. Like Dr. A said, I am Amy Sink, and I'm one of the math specialists at the Learning Liaisons. And we just love what we get to do here, which is help you feel more competent and confident in your math skills. Help you feel more confident and competent in your math skills. And so we're here every Wednesday just working through problems together. I am in cozy mode today. I threw a sweatshirt on and a headband on because it has just been a long day and it's been a long week. And I'm sure you feel the same. And so I was like, you know what? We're going to go straight cozy tonight. Like sometimes we are not so cozy, but tonight was just a cozy feeling night. And so that is why I am dressed cozy, and I have my dinner here. I've got my water bottle here. We are ready to go. So before we get started, let me know in the comment box where you're from, what test you're prepping for, and what is my get to know you question? What is your favorite ice cream topping? Not favorite ice cream flavor. What is your favorite ice cream topping? So where are you from? What test are you prepping for? And what is your favorite ice cream topping? Hello, Marco. Hello, Barbara. It is good to see you both here. My favorite ice cream topping is probably hot fudge, not chocolate syrup, not fake hot fudge like chocolate syrup warmed up, but like the good fudgy hot fudge that like melts the first half of your ice cream. In fact, I'm actually a huge fan of McDonald's hot fudge sundae. Their hot fudge for some reason is so delicious. And so I'm a huge fan of McDonald's hot fudge sundae. So yeah. So where are you from? What test are you prepping for? And what is your favorite ice cream topping? We are going to go through a variety of problems tonight. You're going to see a variety of problems ranging from pre-K through 12th grade. We have a variety of people in here, and so we will go over a variety of problems. If there is something specific that you want to see me go over in the upcoming weeks, just let me know, and I will add it to my next week's section. Just let me know, and I will add it to my next week's section, and I'll be happy to go over anything that you want to see so that I can help you, because these sessions are for you. They're not for me, they're for you. I mean, I love what I get to do, but I want to make sure that I'm hitting stuff that you're struggling with. And so if you have questions, you can always ask me. Yeah, so without further ado, let's go ahead and get started with the first problem. So before I read this problem, we're coming out the gate with a 6 through 12 problem. But don't worry, if you're pre-K through 6 or K through 6, this is not what all of the problems are going to look like. So don't freak out. Don't fret. You're good. So let's go ahead and look at this first problem. All right. A unit circle is shown with an angle theta radians in standard position. Drawing the angle theta plus pi and labeling the coordinates, the angle intersects the unit circle can be used to show which of the following is true. Cosine of theta plus pi equals cosine. Cosine of theta plus pi equals sine of theta. Cosine of theta plus pi equals negative cosine of theta. Or cosine of theta plus pi equals negative sine of theta. Okay. So this is an interesting problem. This is unit circle, cosine, sine, all of the above. So if you are taking a high school test, 6 through 12, 7 through 12, this is definitely something that you need to know how to do. So we see that we have angle theta, and we have this point, which is P, is cosine sine. Well, that makes sense because the X value represents cosine of theta and the Y value of that point represents sine of theta. That should not be new information for you if you are taking a high school test. What they are asking is if I draw the angle theta plus pi. So if this is theta right here and I draw the angle theta plus pi and I label the coordinates, what is going to be true? What I do notice, and why this is a test taking strategy for everybody. So regardless of whether you're taking 6 through 12 or not, this strategy I'm about to tell you is helpful for everybody. Your answer choices are there to help you. Your answer choices are there, and they kind of can be used as a little cheat system. When I look at these answer choices, I notice that every single answer choice on here is cosine of theta plus pi is what I'm starting with. So if that's what I'm starting with, I can completely ignore this sign over here. It doesn't matter because it doesn't matter because none of my answer choices are starting with sine of theta plus pi. So if I'm doing cosine of theta plus pi, I know I'm adding some sort of value to my theta. So no matter where I land on this unit circle, I'm going to end with some sort of cosine value, not a sine value. I'm not flipping this. I'm not reflecting this. I'm not rotating this. So this is all I'm doing is adding a value to it. So whatever my cosine value is going to be cosine of some sort, unless, well, actually, that's a lie. I'm sorry, because it could be like square root of 3 over 2, comma 1/2, and then it could be 1/2, comma square root of 3 over 2, depending on what you add. So I'm sorry, that is not necessarily true. But what I am starting with is cosine of theta plus pi. That is what we are starting with. Now, what do we know about pi on a unit circle? What do we know about pi on a unit circle? I know that pi represents 180 degrees. If this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then this becomes 0 and 2 pi. So if I'm adding pi, pi is 180 degrees. So if I'm adding pi, then theta plus pi is going to be, if this is theta, pi is going to bring me all the way around to creating that 180 degree angle. So this is the point that I'm going to land at, right? This is the point that I'm going to land at, which means I'm going to end up landing at, if I'm at cosine of theta, then this is going to be negative cosine of theta, because cosine is the x value, and now I'm going into the negative x value. So I'm going to end up with negative cosine of theta, which is really just, if I do x plus pi, I'm going to land on negative x, because that's just how our coordinate grid works. Does that make sense? All right, let's go ahead and move on to our next problem. We started hard out the gate tonight, but I promise you not all of our problems are trig problems. So let's go ahead and look at problem number 2. Heather went out to dinner with 3 friends. The bill before tax and tip cost $184.32. The tax applied to the bill was 6.5%. And they decided to leave a 22% tip after tax. If they decide to split the bill evenly, how much did each person spend? If they decide to split the bill evenly, how much did each person spend? So this is a problem for like anyone really. Pre-K or GK, GK, Praxis Core, K through 6, because this is percentages and stuff, is really 6th grade, and then 6 through 12. So it really hits everybody. Heather went out to dinner with 3 friends. The bill before tax and tip was this. The tax was this, and they left a 22% tip after tax. And they split the bill evenly. So we have multiple steps happening right here. I need to add $184.32 plus tax plus tip. And then I need to divide all of that by how many people. How many people are sharing this bill? 4, not 3. That is error number 1 people are going to make in this problem. They are going to divide it by 3 because they're sharing it with 3 people. However, Heather also is at this dinner. Heather is also at this dinner. So if Heather is at this dinner, then she is also splitting this bill. So we're dividing it by 4 people. Now, a good understanding of percentages and decimals and how to find that is important for this problem, because I'm having to find 6.5% of 184.32 and 22% after tax. So how do I find percentages of total? That of word means multiply. So I need to multiply 184.32 times 6.5%. However, my little handy dandy 4-function calculator doesn't have the ability, well, mine might, because my iPhone got I'm going to actually, wow. My 4-function calculator actually has, can you see it? I don't know if you can, it might be too bright. Actually has a percentage sign. So I can literally type in $184.32 times 6.2 percentage sign, and it will give me the correct answer. That, I have not tried that. That is crazy. I can assure you that most of you, when you are handed your 4-function calculator, are not going to have that ability. So we're going to talk about how to do this without that function. So in order to change that percent into a decimal, which is what I need to do to be able to punch it into most 4-function old school calculators, I need to hop that decimal 2 places to the left. So keep in mind, percentages, fractions, and decimals are all in the same family. Ratios too. So really, 6.5% is the same thing as 0.065, is the same thing as 65 over 1,000, is the same, like all of these things. So I need to hop this decimal 2 places over to create a decimal for this percent. So 184.32 times 0.065. Now I can plug that into my old school 4-function calculator, and it will give me $11.98. Now it says $11.98.08. When I round this, a 0 tells me not to round, like I just stay where I'm at. And so I'm just going to end up staying at $11.98. That is the tax. So I'm going to add that to my total. So 184.32 plus 1198. Now I need to add that before I calculate this tip, because it says they decided to leave, this is important, they decided to leave a 22% tip after tax. They decided to leave a 22% tip after tax. So I have to do the tax first and then my tip. 184.32 plus 1198. So this equals 196.3. Add my tip, divide by 4. Like that's how I'm kind of workflowing this out. 196.3, I need to then add my tip and divide by 4. So I need to figure out what my tip is. How do I figure out what my 22% tip is on $184.32? Multiply 196.3 times 22%. Good. But I need to transition this percentage into a decimal. I have an imaginary decimal right here. So if there is no decimal embedded into your percent, you put an imaginary one at the end and then you hop it. 1, 2. So that equals 196.3 times 0.22. Whereas in this example, the decimal was already here. And so when I hopped it, I didn't have to plop a decimal here. Another common mistake people will make is they will say that 6.5% equals 0.06. Sorry, 0.65 because we are so accustomed to seeing decimals from percents be two places, but we need to be careful because 0.65 is actually 65%. So these do not equal each other. That's another common error that people will make. Or like if you have error analysis, like if it's like, where did the student make their error? That's a common place. So in my calculator, I'm going to do 196.3 times 0.22, and that's going to equal $43.18 with a 6 at the end. And if we know how to round, that 8 is going to round up to a 9 because the 6 is greater than 5. And remember, anything 5 or greater rounds us up. Anything 4 or less rounds us down. So this becomes $43.19. So my tip is $43.19. Are you noticing how having this workflow established before I started doing any math is helpful? Because if I didn't have it, I could very easily get lost in the weeds. Anytime you have a multi-step problem, it's really helpful to establish that workflow first. So 196.3 plus 43.19 is 239.49 divided by 4. And when I divide that by 4, that equals $59.87. Now, this problem originally said, this is why the answer choices are not correct. This problem originally said, how much is the total bill before they split it? However, I wanted to change the problem up just a little bit. And so I changed the problem up, but forgot to change my answer choices that I had here. So this says, if they split the bill evenly, what is it? And it's $59.87 because you notice the answer choices had $239.49 and none of the answer choices were $59. So it's just because I changed the question. That's all. All right. Questions about that one? Let's go ahead and move on to problem number 3. Write an equation in point slope form for a line that passes through the point -3, and is perpendicular, that's important, to -2x plus 5y equals 20. So we notice that in this problem, they're asking for an equation in point slope form. What is point slope form? What is point slope form? Y minus y1 equals m times x minus x1, where m is your slope and x1, y1 is your point. Point slope form. You notice that mathematicians are not creative when they name things. So we're passing through the point -3. We're passing through the point -3. So my point slope form is going to start with y minus y1 equals m times x minus x1. If I've been given a point -3, I can literally plug in my x and my y. Now, if you're an elementary teacher and you don't need to know how to do this, you still need to know how to do coordinate points. You still need to know that the x comes first and then the y. So I'm going to plug in 0 for my y, and -3 for my x. Y minus 0, x minus -3. Now, you notice that you have a negative negative. That is going to turn into one big positive because a negative times a negative is a positive. But did you notice how I wrote out the formula first, and then I put blanks, and I plugged in my exact point into those blanks? A common error, and I'm telling you all of these common errors because part of your test is likely going to be analyzing student errors. A common error is going to be that kids are going to put y minus y1 equals m times x minus x1, and they're just going to put x minus 3 rather than x minus -3, which is actually a positive. Common error. Now, I am not even going to find my slope because when I look at my answer choices, I notice that I only have one possibility. That is y minus 0 and x plus 3. There is literally only one answer choice that has y minus 0 and x plus 3. Crazy. That is wild, right? So that is obviously going to be my answer choice. Now, what if they had multiple of y minus 0 and x plus 3? Well, then you would need to know how to find the slope. So now we need to figure out what the slope is. So they gave us this piece of information. Write the equation for a line that is perpendicular to this. Why would they give us that information? What part of that information is helpful for us? As soon as I see perpendicular, I think, that right there is going to be my slope information. Remember, parallel lines have the same slope. And I have to reconnect my iPad. Perpendicular lines, and I'm going to hold on that one until we reconnect, because that's the important piece for this one right here. Parallel lines have the same slope. Perpendicular lines, drum roll, here's the big moment. Perpendicular lines have negative reciprocal slopes, which means if the line, the original line is A over B, then the new line is going to be negative B over A. How do I figure out the slope of this line so that I can then figure out what the slope of my line is going to be? I need to put it in slope-intercept form. This is standard form, which means it's not helpful at all. So I'm going to rewrite it. Negative 2x plus 5y equals 20. I need to get it into y equals mx plus b form. So all I'm going to do is add things, multiply things, divide things until I'm left with y. Add 2x to both sides. So I have 5y equals 2x plus 20. Divide both sides by 5. And I get y equals 2/5 x plus 4. And I notice that I have another error on this slide. I have the parallel slope. There we go. But that strategy, so we're going to talk about that strategy in a minute. That strategy still works moving forward, and I'll explain why. So this right here is my slope of my original line. My perpendicular line is going to be the negative flip. So my new slope is going to be negative 5/2. Now, clearly, I made the error here. I had the wrong slope here. However, that test-taking strategy, if you are 100% confident that you have all of this correct, if you are 100% confident that you have all of that correct, then you can use process of elimination and still come to the conclusion that that would be your answer. You don't need to be worried that like, oh no, they had the wrong slope. They're not going to have the wrong slope. It's a test, like a teacher test. They're not going to have the wrong slope. I had the wrong slope because I'm a human error that didn't check my answer choices right here. But you can be confident that they're not going to have the wrong slope. And so if that's the only answer choice that has the correct Y and the correct X, then that's going to be your answer choice. All right, let's move on to problem number 4. Remember, as I'm working through these problems, you got to make sure you let me know, what do you want to see me go over in the upcoming weeks? What do you want to see me go over in the upcoming weeks? I'm happy to add it to my list of things to chat about. So keep that in mind while I go over the next problem. Describe the transformation that occurred from the equation f of x equals x plus 3 squared to the graph of the equation f of x equals 1/2 parentheses x minus 4 parentheses squared plus 1. Shifted 1 unit to the left, shifted 1 unit up, and a vertical stretch of 1/2. Shifted 4 units to the right, shifted 1 unit up, and a vertical compression of a factor of 1/2. Shifted 7 units to the right, shifted 1 unit up, and a vertical compression of a factor of 1/2. Or shifted 3 units to the left, shifted 1 unit up, and a vertical stretch of a factor of 1/2. All right. Here's the error. We're on like a little error trend today. The error that people are going to make here is that they are going to look at the transformation of this graph compared to the original f of x equals x graph, or x squared graph is what I should say. That is the number one error people are going to make. But what they asked us to do is describe the transformation from this graph to this graph, not from our original, our OG, to this graph, which is 90% of the time what we're doing. So if I look at my original, my OG, and my new, let's call this x squared. Let's call this x plus 3 squared. And let's call this the blue equation. So if I have my x squared graph, I know just because if I'm taking the 6 through 12 test, I'm going to have my parent functions in my head. This is what my parent function looks like. It's a parabola centered around the origin. My original graph that they gave me is x plus 3 squared. Well, I know that an internal transformation moves me right or left because it's right next to the x. And I'm going to go in the opposite direction of what I think. So plus is going to be negative. So I'm going to move this graph 3 units to the right. So that means that this graph right here is shifted how? It's still shifted 1 unit up because there was no vertical shift here, which means that the vertical shift here is still going to be 1 unit up. So I'm going to cross off any graph that says anything other than 1 unit up. 1 unit up, 1 unit up, 1 unit up, 1 unit up. Fantastic. That did not help me eliminate any of my answer choices. So now let's look at the next piece. I'm looking at how I am shifted here. I have x minus 4. Well, x minus 4 is going to be 4 units to the right, which means how many units away is this new graph from my original graph, not my OG? 4 plus 3 is 7. 7 units to the right of this graph. 1 unit to the left? Nope. 4 units to the right would be the right answer if we were shifting this graph, but we're not. 7 units to the right? Yes. 3 units to the left? Nope. We found our answer. That was an interesting question, wasn't it? All right. Marcos, probabilities. Anything specific with probabilities? Remind me what test you're taking. I feel like you're doing 6 through 12, 7 through 12, but I could be wrong. Because that will change drastically what kind of probabilities we talk about. So just let me know what kinds of probabilities. I must say, probabilities are not my favorite. We all have our favorite things, right? Algebra, trig, I love all of that. Probabilities, oof. I will do it for you, but they are not my favorite either. All right, let's go ahead and we have time for 2 more problems, and they are for my elementary friends tonight. We're going to close out with elementary problems, and we're going to end a couple of minutes early just because my husband is working late tonight, and so I have to take care of the little one. So we're going to do 2 more problems, and then we will close out for the evening. A first grade teacher is teaching a unit on time. Which of the following skills is appropriate for first grade students? Which of the following skills is appropriate for first grade students? Telling time to the nearest minute, telling time to the nearest 5 minutes, telling time to the nearest hour, determining the elapsed time between 2 events. So this is an interesting question. And if you have this question on your test, you need to know your state standards. It is important that you know your state standards to be able to answer this question. So I wouldn't suggest that you spend a bunch of time studying your state standards, but I definitely would know generally what each grade is teaching, especially if you're taking the elementary test. So first grade, I want us to just review. Kindergarten doesn't do time. They might do parts of a clock, but they don't do time. First grade typically, don't quote me on this because each state might be a little different, typically does time to the hour and half hour. Second grade typically does time to the nearest minute. And third grade does elapsed time. So with that information, we can deduce that first grade would be doing time to the nearest hour, which then means that if we are a second grade teacher, they would be doing what? Time to the nearest minute. You're absolutely right. Combinations and permutations. You got it. I will add that specifically combos and permutations. Awesome. Anything else that you want to see me go over in the upcoming weeks, let me know. I'm going to turn it back over to Dr. A, and I will see you guys next week. I'm excited to see you guys next week. Let me know in the comment box if there's anything else you want to see me go over, and I hope that you have a great rest of your week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.